Good morning. Today is June 2, 2020, and our subject is Electric and Electronics Fundamentals 3. Our topic for today is sinusoidal alternating current amplitude measurement, and the objective of which are number 1, to perform the actual amplitude measurement of a sinusoidal alternating current using oscilloscope, and number 2, to determine the peak value and effective value or VRMS of a sinusoidal alternating current. But before we start, let us discuss first some of the important parameters of an alternating current. So, as you can see here, we have a one cycle of sinusoidal waveform or alternating current. So these are some of the important parameters. So this point up to this point is called the B peak. So from here up to that point, that is called B peak. Then this dashed line here is representing the VRMS or the effective value of a sinusoidal waveform. So of course this is the half cycle, then you have here the full cycle. So this is the positive cycle, this is the negative cycle. So you have here the B peak, and then this one is VRMS positive. Here you have the negative VRMS, and then you have the negative B peak. So what we are going to measure today is this B peak from here, from this line up to this. So that is your B peak, and also from here, okay, from this lower peak up to that upper peak. So that is called peak to peak or B peak to peak. So we have here a setup. So we are going to use, of course, this digital multimeter. Then you have here the function generator. This is the source of AC. So we have an AC waveform. So this is set at 5 volts. By the way, this 5 volts is a peak value. Then the frequency is 60 Hertz. Then of course, this is the oscilloscope. By the way, I presume that you already know some of the basic of oscilloscope, how to calibrate and how to use oscilloscope. And of course also this one, function generator. So this is the source of our sine wave. So for this, in our previous activity, we already have example here, but this time we are going to use 10 volts. So we'll make this one 10 volts peak. Okay, so let's try to measure the B peak to peak and then the B peak using oscilloscope. So this is the output. This is the output of function generator. I will connect to the probe of oscilloscope. So it's like this. So you connect, and then first make sure that they will not touch each other to avoid short circuit. So this is our connection, and as you can see here, this is more than, so we have to adjust. Okay, so as you can see here, the peak to peak value is 20.6. Okay, and then the maximum or the peak is 10.4. So we are going now to record it here on our table. So the peak is, okay, let's start. The peak is 20.4, no? Peak to peak, 20.4 volts. And then by the way, this is 20.6, and then the B peak is 10.4 volts. Then we're going to draw the waveform. So let's try to draw the waveform. So how many divisions? So let's say from peak up to this. So we try to adjust. Okay. So exactly from here up to here you have 1, 2, 3, 4. So there are how many boxes? 1, 2, 3, 4. So four boxes from this up to this line. So let's try to draw it here. So from here, this is a middle. So 1, 2, here. Okay. Two on the positive cycle and then two on the lower cycle. Okay. So as you can see here, so peak to peak value is from this point up to this point. So we have 1, 2, 3, 4 divisions. So 20.6. Our source here is 10 volts peak. So this is from the function generator. Now let us try to measure using this digital multimeter. So I will remove now this one. And then I will connect the output of the function generator to this digital multimeter. So I connect this one to negative and then to the positive. But it doesn't matter because we are measuring AC, so we can interchange the connection. So you have here now the output of this is connected to the output the digital multimeter. So this is now the value 7.1 RMS. So I write here VRMS is equal to 7.01 volt. So here, no, that is the BRMS. So this one BRMS. Now if we are going to compare the value, let's try to compute using the formula. So this is of course 0.707 multiplied by the peak value. So our peak value is here 10 volts. So let's use the formula. VRMS is equal to 0.707 times 10. So that will give us 7.07 volt. Okay, so by using your calculator, you can easily get the answer. So as you can see here, we have the computed value VRMS is equal to 0.707 times 10. That is the peak value, which is this one, and we got the value of 7.07 volt. So, we're able to measure the peak and peak-to-peak value and BRMS of a sinusoidal alternating current. And as you can see from our result, the measured and the computed value are very near. So we can say that and we prove that the measured and the computed value are almost the same, and we're able to get our objective. So I hope you understand our topic and try to analyze and practice solving using this simple formula. Good day, Group A, D, and C, and good luck. This is Teacher Ed.